Good morning, everyone. My name is Prakash, and I am from Mechanical Department. Today, I would like to discuss about a few basics on mechanics of solids. So, today we would like to discuss about types of beams and different types of loads acting on the beams and different types of supports. So, beams. So here beams are nothing but here it is a horizontal structural member. These beams are designed to support the applied vertical loads. So due to the action of loads on the beams involves combination of two stresses or simply combination of two effects, that is either bending or either shearing. So here you can see in the image, this is a simply supported beam and a vertical load is acting at the center of the beam. So by the action of load on this beam, it involves and it exhibits either bending or it exhibits either shearing. So the two effects are developed in those beams by the action of the load. So coming to the types of beams, there are four or five types of beams. Those are, the first one is cantilever beam. So it is a beam whose one end is fixed and the other end is free. So the examples for the cantilever beams are, so these are the cantilever beams. And next is simply supported beam. So simply supported beam is a beam whose ends are supported or freely rest on the walls or columns of a knife edges. So simply this is a simply supported beam and a vertical load P is acting at the center of the beam, and this is the best example for simply supported beam. And next one is overhanging beam. So in overhanging beam, one or both ends of the project bay or ends of the beam beyond the supports, the beam is continuous beyond the supports, is called overhanging beam. So the best examples are these. So here up to this support, in simply supported beam, thus the supports are at the ends of the beam, but in overhanging beam, the supports, the beam should be overhanged beyond the supports. Coming to the fixed beams, here both the ends of the beams are fixed and built into or simply built into walls or columns. So the best example for overhanging beams is this, and this is the example for fixed beams. And next, continuous beams. So when the beams having more than two supports are called continuous beams. The best examples are bridges. So here these are the different types of beams which we have discussed now. Cantilever, simply supported, overhanging, continuous, fixed, and cantilever beam. Cantilever, simply supported. So coming to the types of loads. So there are three types of loads which are acting on a beams. So the first one is concentrated load or a point load. So here the concentrated load point load is act at any point on the beam. So this is the best example for point load. Here this is a beam which is one end of the beam is rested on the roller support, and another one is this is the roller supports, and here W1, W2 and W3 are the point loads or concentrated loads which are acting at 3 points of the beam. And the second one is uniformly distributed load. So here the load is distributed over the length of the beam. So at any point of the beam, the load remains constant. That means the load acting on the beam at any point is constant in uniformly distributed load. So and the third load is uniformly varying load. So here the load is increased over the length of the beam from one side. So here from this end, from the left end, the load is small. From left to right, the load can get increased. So this type of load is called uniformly varying load. So due to this action of loads on beams, here I will say previously bending and shear occurs in the beams. So this is the bending due to the load, and this is the shearing due to the application of load. So coming to the supports. So there are different types of supports, and the first one is roller support. So roller supports are free to rotate and translate along the surface upon which the roller rests. So here the surface can be horizontal, vertical or sloped at any angle. So in this roller support, it is the smooth pin and it is the rigid body which is connected to this pin, and this is the bracket, and beyond down the bracket, bottom of the bracket, the rollers are present. So these roller supports are free to rotate. It can rotate in any direction, and also it can translate along the surface. So opposite to that roller supports, the reaction forces are developed opposite to the applied load. So second one is hinge support. So a hinge support can resist both vertical and horizontal forces but not a movement. They will allow the structural member to rotate but not to translate in any direction. So in hinge support, only the structural member can rotate but not to translate in any direction, either x direction or y direction. The body will not move in any direction, but it can rotate. So these are the best examples for hinge support. So these are the images for both hinge and roller supports. And the third one is fixed support. So here fixed support can resist both vertical and horizontal forces, and also as well as movement. So that means they restrict both rotation and translation. So these fixed supports are also known as rigid supports. So here, due to the action of load, the body should be bended like this. Here the center layer is called as the neutral layer, and the neutral layer, the layers above this neutral layer are compressed, and the layers below the neutral layers are tensed. That means the upper portion of the beam is undergone compression, and the lower portion of the beam undergone tension. So coming to the shear force, the shearing will takes place at the ends of the supports or at the load acting on that point. So these are the few basics of mechanics of solids, that means the types of loads and types of beams and also types of supports. Thank you.